So I live and work at the Polish Polar Station, and I work here as a meteorologist, but as for my education, I'm a geographer with a specialization in hydrology, so actually we could say that I'm a hydrologist. And today I would like to tell you a little bit about polar day and polar night in the Arctic. So let's start. So let's start with the basic definitions. What is the polar day and what is the polar night? Well, both day and night are natural phenomena in which the sun occurs above or below the horizon for at least 2 hours. In the case of polar day, it means that the sun is visible 24 hours above the horizon, and that's why we call this phenomena midnight sun. In the case of the polar night, it is the other way around. The sun is invisible all day because it's below the horizon. So that's the base. Both of these phenomena occur both in the northern and southern hemisphere, but only in areas located between the polar circle and the pole, so in the polar regions. Both the day and the polar night are characterized by different lengths. These lengths depend on the place where we are and precisely from the latitude. The further north or south of the polar circles, the longer this phenomena lasts. For example, on the polar circle, it will be only 24 hours, where here, where I am, about 3 months, and at the pole itself, 6 months. Is it also worth remembering that the polar day alternates with the polar night? What does it mean? When the polar night lasts at the North Pole, at the same time, the polar day lasts at the South Pole and vice versa. Here you have the illustration of the midnight sun. How does it look like? So as you can see, the sun is visible for 24 hours. It's not going down below the horizon. Around, let's say, midnight, it's quite low, but still you can see the sun. So I have a question for you. Is the polar night as dark as a normal night? How do you think? So I can tell you that actually the polar night is brighter. It's usually brighter than the normal night. Why? First of all, it's due to the phenomenon of atmospheric refraction. During long periods of the polar night, the sun is below the horizon, but still close enough that we can observe something like a several hour long dawn or twilight, despite the fact that neither the sunrise nor the sunset are taking place. I will also talk about that in a moment. In addition, the polar night is usually illuminated by stars, the moon, and often by the northern lights, so aurora. We also have to remember that during the polar night, the land is usually covered with snow and ice, which favors the creation of glare and scattering of darkness. So as you can see on this photo, I took this photo around end of December, so in the, well, period of polar night, and it was so bright that you can see on this photo my shadow, and when we went for a walk, we didn't need to use the flashlights, so it was really bright due to the moon, which was shining because there was no clouds, there was a lot of stars, and there was also aurora. So sometimes polar night is actually quite bright. As I have just told you, when the sun is just below the horizon, its rays continue to reach the higher layers of the atmosphere, where they are dispersed and then reflected towards areas where the polar night is present. This phenomenon is called atmospheric refraction, which is the bending of light rays in the Earth's atmosphere, which causes an apparent shift of the observed position of astronomical objects in the sky. In other words, it seems that, for example, the sun is higher than it really is. So the refraction and size of the sun's disk move the boundary of the polar day several thousand kilometers south of the Arctic Circle, and similarly, the polar night boundary is moved north of the Arctic Circle. This is due to the phenomenon of twilight or dawn, which I will tell you more in a moment. So, we already know that atmospheric refraction causes the phenomenon of twilight and dawn, and we distinguish three types of polar nights depending on the type of twilight or dawn. So that's the civil polar night, nautical polar night, and astronomical polar night. I will describe them in detail on further slides. So we have three types of twilight and dawn, just as you can see on this picture, and three types of polar night related to them. They are distinguished depending on the position of the center of the sun's disk relative to the horizon line. And this position is determined in angular degrees, as you can also see on the picture. And what I can tell you is that only in the case of sunrise and sunset, the upper edge of the solar disk is taken into account. So sunrise occurs when the upper edge of the sun disk is on the horizon line and therefore at 0 degrees. So, civil twilight is the brightest form of twilight. It occurs after sunset when the geometric center of the sun is up to 6 degrees below the horizon. During this period, there is still enough natural sunlight that you don't need any artificial light for outdoor activities because due to atmospheric refraction, it's quite bright outside. You can distinguish the horizon and the objects located on the surface of the Earth. Also, you can observe only the brightest stars by naked eye during this time. And of course, the duration of twilight depends on the current declination of the sun and the latitude of the place where you are. So the farther north we move, the length of twilight will increase, sometimes leading to the so-called phenomenon of white nights. The civil polar night period produces only a faint glow of light visible at midday. It's a period when the center of the sun's disk is between 6 degrees and 12 degrees below the horizon. So it occurs after civil twilight. And yes, as I said, it produces only a faint glow of light visible at midday when a nautical twilight occurs. And on Svalbard, this civil polar night lasts from around 11th of November until 30th of January, more or less. After sunset, when the geometric center of the sun's disk is between 6 and 12 degrees, below the horizon, of course, we are dealing with the second twilight phase called the nautical twilight. During this period, sailors have no problems with navigation because both the brighter stars and the horizon are visible. Objects on the Earth's surface can be difficult to distinguish, and artificial light is needed to conduct outdoor activities. So that's the nautical dawn or twilight. And another type of polar night, which occurs after nautical twilight, is nautical polar night. During this nautical polar night, the sun is lower than 12 degrees below the horizon. And during this period, there is no trace of daylight except around midday, when we deal with, of course, astronomical twilight, which will be the next phase. It happens because there is no nautical twilight anymore, and yes, and only astronomical twilight occurs at the solar culmination, so around midday, just as I said. And in case of Svalbard, this lasts from around mid to late December, but only in the northern part of Svalbard. So, for example, in the New-Ålesund. And astronomical twilight is the darkest of the three twilight phases. It is the earliest stage of dawn in the morning and the last stage of twilight in the evening. During astronomical twilight, the geometric center of the sun disk is between 12 and 18 degrees below the horizon. And in that period, most stars and other celestial objects can be seen with the naked eye, but you have to remember that the horizon line is, of course, invisible. In places like, for example, Poland, the sun does not go below 18 degrees below the horizon. So after astronomical twilight, there is directly the astronomical dawn. So depending on the latitudes, this can take between 23 and up to 88 days. Well, and finally, the last type of the polar night, so the astronomical polar night, I'm sorry, when the sun is lower than 18 degrees below the horizon. And this is the period when it's really actually dark all day. So it's just as dark as during the normal night that we know. But what is worth remembering that this phenomenon can be observed only in areas that are very close to the North Pole, so north of 84 degrees north of south. And at the poles, this period lasts about 11 weeks. So, for example, on the Amundsen-Scott South Pole Station, which is exactly on the South Pole, you can experience that from 15th of May to late July. And in case of the North Pole, you can observe this from 14th of November to almost end of January. All right, so here you can see the illustration of, let's say, borders of different types of polar nights in the Arctic, so in the north. Remember that on the northern hemisphere, 24-hour night is not experienced at latitudes south of 72 degrees north. And astronomical polar night is not observed at any point on Earth's land surface, as you can see on the map. So only 5 settlements, 2 in Canada, I think 2 in Russia, and one in Svalbard, are within the limit of nautical polar night. So this second type of polar night that I was talking about. Of course, this nautical polar night lasts there at least 24 hours. And also you have to remember that the polar night and the polar day, so midnight sun, occur only behind the polar circle, while the twilights and the dawns that I was also talking about, so the civil, nautical, and astronomical ones, also occur on the other geographical latitudes, for example, in Europe. And there are even sites when you can find a precisely calculated time when a given twilight starts or ends on a given day and place on Earth. And I think I can show you one of that websites. So you can choose a city, a month, and a year, and you will see the times of sunrise, sunset, what is the day length, and what time different twilights start. timeanddate.com. You can check your cities and see at what time you can observe different types of twilights. So another question for you: how do you think what causes that for half a year at the pole we have a night, and for half a year a day? So I will help you with that. The occurrence of the phenomenon of the polar day and night is the effect of the Earth's revolution, which means the movement of the Earth around the Sun. As you can see on the picture, this movement is counterclockwise and takes place on an orbit. Yes, exactly. That was a good answer. The position and angle of the Earth within the Sun, exactly. Plus this, so the Earth's revolution. Yes. So as I said, this movement is counterclockwise and takes place on an orbit which shape is similar to an ellipse. One revolution, so one cycle of the Earth around the Sun, takes over 365 days, which we call an astronomical year. However, the Earth's revolution itself is not enough to trigger the phenomenon of the polar night. The missing element is the fact that the Earth is tilted 23 degrees and 27 minutes on its axis. This constant inclination of the Earth during the revolution around the Sun has various consequences. One of them are the seasons of the year. The others are, of course, the difference in the length of day and night, and thus the occurrence of of the polar day and polar night. Difference in lightening of the Earth throughout the year. Also, different places of sunrise and sunset and its height above the horizon, or something which is pretty obvious for us. So the calendar, the count of years. Let's start with the polar day at the North Pole. On 21st of March, the northern and southern hemisphere are illuminated equally, as you can see on this picture. So on the whole Earth, the length of day and night is equal and lasts 12 hours. Therefore, we call this day the spring equinox. At the equinox at the North Pole, the sun rises and stays up all day until the September equinox. During this time, the North Pole does not experience any kind of twilight, and you already know this that this phenomenon is called polar day or midnight sun. And at the same time, the polar night begins at the South Pole. In addition, this is maybe an interesting thing for you. On this day, in all places on Earth, the sun rises exactly in the east and goes down exactly in the west. Also here you can see the day-night cycle graph. How does this look like on equator and South Pole? So as I told you, on the North Pole the polar day begins, while on the South Pole, as you can see, the polar night begins, and of course we start with the civil twilight. And here on the upper picture we can see how it looks like on the beyond the Arctic Circle on the 77 degrees south. So it's a little bit different, but also it starts to have the twilights and so on. Then on June 22nd, the sun is directly over the Tropic of Cancer on the northern hemisphere, and we call it summer solstice, and it's the longest day of the year for that hemisphere. And the closer to the North Pole, of course, the longer the day is, as you can see, because North Pole is being hit with the sun rays. And so yes, behind the Arctic Circle, the sun does not set. There we have there a polar day. And on the southern hemisphere, the situation is opposite. We have the shortest day and the longest night. While behind the Antarctic Circle, there is of course a polar night. And then in September we have again an equinox. So at the North Pole the sun sets, and on the South Pole it rises. And again, here at the bottom, you can see the graph of daylight and night phases on the South Pole, and upper picture is the situation on the equator. So, of course, on equator, it's day and night. It's the same. It's the the cycle is the same throughout the year. And at the South Pole, in June, we are in the middle of the polar night, this astronomical night. Yes, and a little bit higher to the north, it looks it looks quite different. And finally, the cycle is closed by the winter solstice, when on the 22nd of December the sun is directly over the Tropic of Capricorn, and in the northern hemisphere we have the shortest day and the longest night. Obviously, beyond the Arctic Circle we have the polar night, and in the south, beyond the Antarctic Circle, we have the midnight sun. So now you can see that in December at the South Pole we are in the middle of the polar day, so we have daylight. On equinox, it's obvious. On the equator, of course, it's just as any other day. And the same a little bit south of the Antarctic Circle, there is also the midnight sun. All right, and how does this look like at Polish Polar Station Hornsund? As you may know, Polish Polar Station is located at 77 degrees north. So how does this work for us here? Well, generally the beginning of polar night here starts around 31st of October and ends in February, while the polar day starts in April and ends in August. What is important to remember is that nautical and astronomical polar nights do not occur at this latitude, so we do not experience that kind of polar night. So as you can see on this picture, polar night here is not so dark. In fact, on 31st of October, we see the sun for the last time, because the last sunrise and sunset occur. And from that moment on, we only deal with civil twilight. However, usually this period from 31st October to 11th of February is called the polar night here. And here another photo of the polar night. I took this photo around mid-December, so in the darkest period at the station. That's because from the middle of November the civil polar night lasts here, and only from around 10 a.m. to 5 p.m. we are dealing with nautical twilight. And at that time it is a little brighter in the south. But if it's cloudy, then trust me, you cannot see the difference. It's quite dark. And first sunrise appears here around 11th to 13th of February. This year it was on 13th February, and it's conventionally considered to be the end of the polar night. Since that day we have more and more sun, and the days are getting longer, so it's really nice to see the sun again. Midnight sun for us here on in Hornsund starts on 22nd of April. That's the official start of the polar day here. From that moment, the sun will not go down. There will be no sunset until 22nd of August. And here on this photo, you can see. Well, I took that photo actually in the middle of the night, so you can see that it's really the midnight sun. I think I took this photo around after midnight. So that's very, I would say, very nice thing to for me, at least, to have and experience the midnight sun, because, well, no matter what time of the day it is, you have the sun. It's bright. Actually, I can show you that today also we are in the middle, of course, of the polar day, so it's very bright. You can see the helicopter in the front of our station because we have guests today. Norwegians came to visit us. Yeah, so if I would broadcast this lesson after midnight, you wouldn't see the difference outside. It will be just as bright as at the moment. So that's for me. That is a great thing. While during the polar night, of course, some people don't like it because, well, it's dark for 24 hours. And I can tell you that you have a little bit less energy than during the polar day, so you're more sleepy, and well, it is not so easy to work here during that time because you don't see everything, and as you know, you have to also always be aware of polar bears. So you're always wondering whether that ice in the dark that you see are reindeers or maybe polar bears or maybe that's the Arctic fox. So you have to be careful.